Hello all, let us assume we have a PCB, okay, and on this PCB, let us assume we have a regulator, okay, whether it be a switching regulator or an LDO, there is a regulator. Now, let us assume there is a load 1, okay, which actually carries around zero point 0.2 amps, for example, okay, and there is a load 2 which carries around zero point 0.4 amps. Okay, now the output the regulator, let us assume it has a capability of 1.5 amp, and the power traces have to be routed. Let us assume we don't have an option to have power planes. So in this scenario, what is the routing topology that we do prefer while routing the power supply signals? So that's the point of discussion here. Now, in this scenario, let us assume there you have routed a signal initially like this because the LDO is closer to load 1, and from here we have routed the power trace like this, a thicker trace which can accommodate, let us assume, 1 amp of current. Now, what are the disadvantages of routing like this? This is almost a kind of daisy chaining kind of, right? Where you have current passing through, like example, let us assume the load 2 has to be supplied with the current. So in that case, the entire current has to pass through load 1 and has to go to load 2. Okay. Now, let us assume this particular trace has a impedance of R milliohms. Okay. Now, if load 1 and load 2 are powered, okay, that means the voltage that will be dissipated across this trace because of this total current of 0.6 amps, right, is Rm into 0.6. Okay. Now let us assume Rm is 1 milliohm for our just understanding. That means the drop will be 0.6 milliohms, which is not significant. Sorry, 0.6 volt millivolt, which is not a significant voltage drop. That means around 600 microvolt drop is there, which is not a significant drop compared to the voltage that is given. Let us assume if we are giving a 3.3 volts supply. Now, as we go down the supply, let us assume if we are having a 1.2 volt or 1 volt voltage that is being provided with a little higher current, then this voltage drop across this trace increases, and then we have to think about the thresholds, the logic level thresholds, and ultimately at one point, because of this voltage drop, it might lead to interface failure. Now, let us assume if this is 1 amp current and 0.1 amp current, okay, then ultimately what we have to do is we have to route a trace such that the trace at least carries 1 amp current, and ultimately the load 1 also has to handle the 1 amp current. The trace that is routed to the load 1 also has that much thickness. Now this is one kind of routing. If, for example, let us assume we route a trace from this power supply to this load 2 and load 1 individually, like a star routing. Okay, so this is a star routing. Now in this case, we can have a trace, thicker trace, and we can have another trace, and the current of 0.2 amps, as we talked initially, will flow through this. The current of 0.4 amps will flow through this, and ultimately, if we assume that the trace resistance is Rm of each, then ultimately the voltage drop because of this trace will be much lesser comparatively, right? So there are several cases that need to be discussed here. Like if the load 1 has very high current, load 2 has very high current, then the must preferred option is to have star routing here to ensure that you have as much low voltage drop um, because of the traces. Now, if the loads have a very less current, like as we talked, like zero point 0.1 amp or zero point 0.2 amp, where the voltage drop across the load is not so significant, we can route the traces in a daisy chained way. So ultimately, it's all depending on the load current, the amount of impedance. As the trace width increases, the impedance reduces, right? But ultimately, do we have that much space? Because this is a in the beginning we assumed that this is a two-layer board, so we have components all around. Do we have that much space to be routed? So all these scenarios and discussions come into picture. Ultimately, the point here is it is safe to do a star routing in such scenarios. So if you are dividing your placement into various areas where you have a load 1, you have load 2, or several other areas, and you cannot have a power plane, the best option would be to do a star routing in these scenarios. So this is one of the important tip while routing. If you have encountered such scenarios and you did the routing in a different way to avoid the voltage drop across the traces, please do post in the comments. So most of the people, if you observe, prefer to do a star routing in the case of low layer boards to avoid such scenarios. Also, technically, you need not waste the amount of copper that need to be routed if the loads are of different current values. Okay, one having a very high current value and one having a very low current value, you need not route a thicker copper trace to L1. Meanwhile, having a thicker copper trace to another load of higher current is feasible to have. So very simple scenarios, right? And as we mentioned, the routing also has to be decided depending on the kind of voltage that need to be supplied to these loads. Very important tips while routing. Please post your suggestions, comments.